Hello astronauts, let's go into an interesting trip. But before that, I will ask you a question. Haven't you wanted to work at NASA? Haven't you wanted to work at NASA? Yeah, NASA. Let's work at it now. Now I want you to close your eyes and imagine that we are in the Earth and our enemies, the aliens in the nearby planet, our enemies want to invade the Earth and they will come soon to our planet with their spaceships. They want to invade our Earth, but we will not allow to this happen. What should we do? We have our superhero. You, 8th graders, aren't you a superhero? We want from you to save us from these aliens. So, please, tomorrow go to them and save us and punish them. Tomorrow had come, but we found you sleeping. Unfortunately, we found you sleeping. What will happen? We will be invaded from the aliens. But fortunately, their spaceships burned. Their spaceships were burned in the atmospheric envelope. Their spaceships burned up in the atmospheric envelope, burned up thanks to not for the sleeping superhero but the atmospheric envelope. So let's learn about the atmospheric envelope and learn about our lesson. Atmospheric envelope, it's a gaseous envelope surrounding the earth. So this is the earth and we have this envelope around. This is a gaseous envelope surrounding the earth and rotates with the earth around its axis. The earth have an axis and it rotates around it. Also the atmospheric envelope rotates with the earth around its axis, and this envelope extends for about 1000 kilometers above the sea level. We say above sea level, not ground level or anything. We measure from the sea level, not anything else. So what is the atmospheric envelope? The atmospheric envelope, it's a gaseous envelope surrounding the earth that rotates with the earth around its axis and extends for about 1000 kilometers above the sea level. And this atmospheric envelope is called also atmospheric air. So you have to say that atmospheric envelope or atmospheric air. Air forms a gaseous envelope surrounds the earth known as atmospheric envelope or atmospheric air. And let's go to the next point. What is the next point? The atmospheric pressure. What is the atmospheric pressure, mister? We want to measure this pressure. What will happen? We will go to Uncle Gom'a. We will go to Uncle Gom'a, the fruit seller. Uncle Gom'a, the fruit seller. This is Uncle Gom'a. Please, Uncle Gom'a, we want you to measure the mass of something, small something. He will say, of course, 8th graders, I have this balance or this scale, so you have to put it in this plate and I will measure it. So what is the thing that you want to measure? I have told you that it's a small thing. What is that? We have this. This is the sea level. This is the sea, so it is the sea level. I want you to measure the mass of a air column. Air column. Yeah, I want you to measure the air column. Air column. This air column extends to 1000 kilometer. 1000 kilometer, the length of the atmospheric envelope. And this air column is on a area unit. So this column is on area unit, and now I want you to measure it. Unfortunately, Uncle Goma had told me that go away, or I will punish you. I will crack your bones. So I went away, but I want to measure the mass of it. Let's measure the mass of the air column from the sea level, and let's measure this column from this mountain, and also it is on a area unit. You will tell me that the mass of this you will tell me that the mass of this column, the column from the sea level, would be more or have a big mass, and this have a small mass. Why? Can you give me the reason? We will answer this question while we explaining the lesson. Now let's identify the atmospheric pressure. It is the weight of air column of an atmospheric height. So we have this. This is the atmospheric. So if we measure the air column of this air column that is in or on a unit area like 1 meter square, it is the atmospheric pressure. If we measure it from anywhere, but if we measure it from the sea level, it would be normal atmospheric pressure. So if we measure it from the sea level, it would be normal atmospheric pressure. But if we measure it from the top of the mountain, like our example, it would be the atmospheric pressure for this point. So the atmospheric pressure is the weight of air column of an atmospheric height on a unit area. The atmospheric pressure is measured by a unit called bar. So the unit that will measure the atmospheric pressure is bar. So the bar is the unit of atmospheric pressure, and millibar, but bar equal what? Equal 1000 millibar. So bar equal 1000 millibar. And take this information. The atmospheric pressure at the sea level is known as normal atmospheric pressure, as I told you. And it equals what? It equals 1013.25 millibar. But if I want to measure it with bar, I don't need millibar. I want bar. What will you do? It will equal that 1 bar point 01325. So it equal 1013.25 millibar, or 1 bar, طبعا 1 bar point 01325 bar. The bar is a big unit, and millibar is a small unit. It's like what? It's like the meter and millimeter. The meter equal 1000 millimeter. They are the same thing. Let's do this experiment to know about the atmospheric pressure. If we have 3 spheres of clay, this clay, red, blue and yellow, if we put them at like this figure, we put a book and a plastic sheet, then piece of clay, then book, then sheet of plastic sheet, and clay, plastic sheet, book, plastic sheet, clay, and plastic sheet, book. You may notice that, or notice that, you may notice that the conclusion that change in shape, the shape of clay spheres increases the number of books. This sphere, this clay, it may be like the same, like there's no change on it. But the second one, you will notice a change, a mid change. But the third one, you will notice the what? You will notice the great change on it, because this piece of clay have many books and many something on it. So the conclusion is that the change in the shape of clay spheres increases by increasing the number of books or height in our atmospheric pressure, due to the increase in their weights or pressure, and vice versa. The clay, or the one who are in the top of this figure, there is no change on it. Yeah, maybe there is no change, maybe, but the last one on this, it has a great change on it. The shape of it is clearly is completely changed. It's completely changed. So what will you do? At this figure, it's like our example. Similarly, the atmospheric pressure decreases on going above the sea level. So if you measure the pressure here, it would be 710 millibar. But if you want to measure it in the sea level, it would be like that, 1000 millibar. So what happened here? Due to the decreasing the length, due to decreasing the length of air, there is a decrease here, decrease in the length of air, column, and thus its weight decreases. So here I will show you now. Here you have this column to measure its mass, but here you will measure this column, just this column. It's a short column, so due to decreasing the length of air column, and thus its weight decreases. So it is the answer. And another question: the atmospheric pressure increases on going under the sea level due to increasing the length of air column, and thus its weight increases, like that. This air column is very taller than that, so it's have a more pressure on it. The last question in this point: the atmospheric pressure differs from an area to another on the Earth's surface due to the difference in the length of air column from an area to another area. So you have this is like mountain, and this like sea, and this and this high mountain, small mountain. If you measure the pressure here, It will differ from here, from here, from here. It will differ because the length of the air column differ from each place. Differ in each place. You have a new air column in length. And the length would be different. The length of air column would be different. And now take this note. It's an incredible information. You will know that 90% of the mass of the atmospheric air is present up to 16 kilometer height above the sea level. So 90% of the mass of atmospheric air is present up to 16 kilometer height above the sea level. 90%. Do you imagine that? 90% in 16 kilometers. And 50% of the mass of atmospheric air is present up to 3 kilometers. So 3 kilometers. I want you to brainstorm this question. What happens to the density of air ongoing above sea level? Going above sea level, the density would be more, or it would be high, or would be low. Of course, the density of air ongoing above sea level in these high points, it would be decrease. The density of air decreases when we move from here to here. The density would decrease. So the density of air ongoing above sea level, the density of air decrease. The density of air decrease, and the high density is here. The high density of air here, and the low density is here. And I will tell you something. The hot air has a low density, and the cold air has a high density. So the cold air is on the bottom here, in the bottom of this column, and and vice versa. The high density of air is in the top of this column. Note, density of air at the top of a mountain is less than its density at the foot of the mountain. The foot of the mountain has air, its density is low, and the top of mountain has air, its density is the top of mountain has air, its density is high or low. It's low. Its density is low, and in the foot, its density is what? Is high. The density of air is high, cold air. So please answer this question. Rearrange the values of atmospheric pressure according to the given arranged elevation above the sea level. Elevation above sea level. There is here 3 kilometers, 6 kilometers, 9 and 12. Can you rearrange this atmospheric pressure? Its unit millibar. Yeah, I will tell you something. If you have a small height, you have a high density. Small height, high density. Small height, high density. So small height, high or pressure, high density, and high pressure, and vice versa. High height, you will have a small pressure and small density. We have two instruments that measure the atmospheric pressure. Aneroid, it is the name of this instrument. This is its figure. This instrument is used to determine the possible day weather. So it's important to know the weather based on the atmospheric pressure. So aneroid, it is used to determine the possible day weather based on the atmospheric pressure. Altimeter is the second instrument. It is used in aeroplanes to measure the elevation of navigation based on the atmospheric pressure. So this based on atmospheric pressure, and this based on the atmospheric pressure. This is used to determine the possible day weather, and this is used in aeroplanes to measure the elevation of navigation, This is an aeroplane to measure the elevation of navigation based on the atmospheric pressure. So you have aneroid and altimeter. You know now its importance. One to determine the possible day weather, and the second one is to measure the elevation of navigation in aeroplanes. Haven't you ever watched the weather forecast in the news? Haven't you ever watched? You will see, if you watch it, you will see this map, atmospheric pressure map. The TV presenters used this map to know the direction of the wind, to know the wind direction. So what is this map? This is the atmospheric pressure map. This atmospheric pressure map has many points. This point has the same pressure, so we will attach between them with a line. This line is called isobar. So isobar, curved lines that join the points of equal pressure. So this point have equal pressure. Curved lines that join points of equal pressure in atmospheric pressure maps. So isobar, curved lines that join points of equal pressure in atmospheric pressure maps. This is the isobar, and this is the atmospheric pressure map. The center of high atmospheric pressure areas is represented by high. The center of high atmospheric pressure areas is represented by high, like H, high, H. And the center of low atmospheric pressure areas is represented by low, L is represented by low. And what is the importance? These maps will show you the wind direction. The wind moves from the high pressure, like this point, to low pressure, like this point. So the importance, the atmospheric pressure maps, they are used to detect the direction of winds as winds move from the areas of high atmospheric pressure to the areas of low atmospheric pressure. So this is the importance of the atmospheric pressure maps, and these lines is called isobars. These lines will attract between the points that has or have equal pressure. These have equal pressure. Let's answer this question. Give me the reason wind moves from an area to another on the Earth's surface. I will say that due to the difference in the atmospheric pressure from an area to another on the Earth's surface. Where the wind moves from, it is the important thing. The wind moved from the areas of high atmospheric pressure to the areas that has low atmospheric pressure. So from high to low atmospheric pressure, this is the answer for this question. And now let's move to an interesting point in our lesson: layers of the atmospheric envelope. Layers of atmospheric envelope. The atmospheric envelope consists of 4 layers above sea level, which are classified according to the change in atmospheric pressure and the change in temperature. Layers of the atmospheric envelope: the first one is troposphere, the second one stratosphere, 3 mesosphere and thermosphere. So tropo, strato, meso, thermosphere. Look at this. This is the layers of the atmospheric envelope. You will notice something. Troposphere has the clouds. Stratosphere has, oh, there is a plane here, so what does that mean? And mesosphere, there is a meteors, and the third one, thermosphere, has something light. It's a green light or something on it. So there is a region between each 2 successive layers. In this region, temperature remain constant. These region are, we have here between troposphere and stratosphere something is called tropopause, and we have here between stratosphere and mesosphere something is called our layer, or something is called stratopause, and here we have mesopause. Tropopause is the region between troposphere and stratosphere. Stratosphere is the region between stratosphere and mesosphere. Mesopause is the region between mesosphere and thermosphere. You have to memorize all these concepts, or all these terms. And now let's go to the first layer of the atmospheric envelope layers. The first one is called troposphere. It means a distributed layer, because all atmospheric turbulences or weather changes take place in it. So troposphere has all the weather changes, all these hard things, or all the turbulences, all the weather changes happen in the troposphere layer, and the location of it is the first layer of atmospheric envelope. This is the atmosphere. It is the first layer of the atmospheric envelope. You will notice that this layer extends for what? Extends for about 13 kilometer. Extends for about 13 kilometer above sea level to tropopause. Extends for about 13 kilometer above sea level to the tropopause. The thickness of the troposphere layer is 13 kilometers. The thickness of this layer is 13 kilometers. 13 kilometers. Extends for about 13 above the sea level to tropopause. And tropopause is the region between the troposphere and the stratosphere. As I told you, the atmospheric pressure in this layer decreases as we go up. I told you that the pressure decreases as we go up until it becomes 100 millibar, nearly at its top. So at its top, the pressure equals that 100 millibar. 100 millibar is the pressure on the top of the troposphere layers or layer. 100 millibar equal 0.1 bar, so the atmospheric pressure at its top is equal to 0.1 of the normal atmospheric pressure at the sea level. At the sea level, as you know that it's like that. The atmospheric pressure at the sea level equal nearly like that, or something like that, one and some fraction, so it's 1. So if we say the pressure is 0.1 of the normal atmospheric, that's equal. The importance of troposphere. All weather phenomena are present in troposphere layer. Can you give me the reason? Because it contains about 75% of the total mass of the atmospheric air. Atmospheric air. We say that in 16 kilometer you have 90%, and in 3 kilometers, 3 kilometers you have what? You have what in 3 kilometers? You have 50%. And in the middle, you know that the troposphere is the troposphere thickness equal 13 kilometer. 13 kilometer. So in up to 13 kilometer you have 75% of total mass. 75% of total mass, it is in the middle. And the second question, give me the reason troposphere layer organizes the Earth's temperature. Troposphere layer organizes the Earth's temperature. How it come? Because it contains what? It contains 99% of the total atmospheric water vapor. Yeah, the troposphere has 75 of the total mass of the atmospheric air, but it has 99% of the water vapor. So troposphere layer organizes the Earth's temperature because it has the most water vapor in the atmospheric envelope. And note, weather phenomena such as rains, wind, clouds, etc. take place in troposphere layer. I have told you that the troposphere it is the layer in which the weather changes happen. So this weather phenomena happen in this troposphere layer that form the weather condition and consequently the climate that affect the activities of living organisms. So all the weather changes happen on it. And the air movement. The air movement in this layer is vertical. It's vertical. How that happen? The air movement in this layer is vertical. Vertical like what? Vertical like this. Vertical like this or like this. Oh, vertical like this. Like this and like this. And this is horizontal. So vertical is like this. Like this. So because the hot air currents move upward while the cold air currents move downward. So you have two things. The first thing is that you have a hot air currents move upward and cold air currents move downward. So the air movement in this layer is vertical, not horizontal, as you may imagine it horizontal, but it's vertical because we have hot air and cold air. The hot air will move upward and the cold air will move downward. Now take this information. The temperature of this layer decreases at rate 6.5 degree for each 1 kilometer height until it reaches the lowest value of about minus 60 degree at tropopause. The degree in the sea level in this figure is like that, is 19.5, and we will move 1 kilometer, so it will decrease by 6.5. 19.5 minus 6.5 equals 13, and then 13 minus 6.5 equals 6.5. 6.5 minus 6.5, it would be 0. 0 minus 6.5, it would be minus 6.5. So when you move 1 kilometer upward, the degree will decrease. The degree will decrease. Degree will decrease 6.5 degree. So but you may in social you take this information like that. If you move 150 meter, what will happen? Will happen that 150 meter, the rate of decreasing would be 1 degree. But here we have what? Here we have 1 kilometer, not 150, 1 kilometer. So we have 1,000 meter. So if 150 the decrease would be 1 degree. So if we have 1,000, it would be what? It would be x. So we will calculate it. That's x equal what? 1,000 times 1 over 150. That's equal 6.5 Celsius degree. So they are the same. They are the same information. The information in the science and the information in the social. They are the same information, but they gave it to you in new way. So we can calculate the amount of a change in the temperature in troposphere layer using the following relation. The amount of a change in temperature, decrease or increase, equal the height above sea level times 6.5. 6.5, the amount of change in temperature. The amount of change in temperature. So we have this formula. If you want to measure the change in temperature, you have to what? Multiply 6.5 with height above sea level, and vice versa. If you want to measure the height, you will divide the change in temperature by 6.5. This is the law of the change in temperature. But we have another law. The temperature at top of mountain, or they are the same or not? The temperature of at the top of mountain, the temperature at its foot minus the amount of decrease in temperature. The temperature at the foot mountain equal the temperature at its top plus the amount of increase in temperature. Now let's solve this problem. If the temperature at the foot of Everest, this is Everest, and this is the foot of Everest mountain, is 20.6 degree. Find the temperature at its top of height 8,862 in above the sea level. We want to measure that, the degree here. First we will calculate the height, but in kilometers. We have this in meters, so we will calculate it in kilometer. We will divide this number by 1000. It will equal 8.8 kilometer. The amount of decrease in temperature equal that, the height above the sea level times the 6.5. So this amount times 6.5 equal 57.6 degree. But we want to find the temperature at its top. Temperature at the top of the mountain equal temperature at its foot minus the amount of decrease in temperature. Result would be minus 37 Celsius. Let's move to another question. Calculate the height of a mountain if you know that the temperature at its foot is 12 degree and its top is minus 6. We want to calculate the amount of a change. The amount of a change is that temperature at the foot minus temperature at the top. So 20 minus 6 equal minus and minus, it would be plus, so that's equal 26 degree. But we want to calculate the height, so we will do that, the amount of a change over 6.5, it would be 4 kilometers. And the last question in our session says that from the opposite figure calculate the temperature at point A, the vertical distance between point A and point C, point P and point C. Here this is the distance, so we want to calculate this, the vertical distance. We want the vertical distance, so we want to calculate this. 4 kilometer equal this distance. The vertical distance between point P and point C, if you know that the temperature at point B equal minus 5, so here is minus 5, and C is 27.5. So the first thing, we will calculate the amount of increase in temperature between B and A, the height above sea level, times 6.5. The height is 4 times 6.5, so 26 is the amount of increase in temperature. The second thing, the temperature at point A equal the temperature at point P plus the amount of increase, so we will use that. The temperature is minus 5 and the amount of increase is 26, so the result is 21 Celsius. And the last thing, the amount of change in temperature between C and B, the temperature at point C minus the temperature at point P, that's equal 32.5. But we need what? We don't need the degree. We need the vertical distance between the 2 points. It will be like that. The amount of a change over 6.5, it would be 5 kilometers. So this distance is 1 kilometer, and 1 kilometer plus 4, it equal 5 kilometer. And that's all for today. We will continue in the next video. If this video was useful for you, please press like and give us a nice comment and subscribe on this channel. And finally, I will say سبحانك الله وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك ودمت في أمان الله. والسلام عليكم ورحمة الله وبركاته.